Sorry, Karina, you're gone. Here are the even answers, and we're scrolling quick. It's Milani's birthday. You're missing it. Alright, I'm scrolling. Pause if you need them longer, Karina. There's 20. There's the answer. There's 34. 46. And we're done. Okay. Luca, you were going to sing? Yeah, keep going.
You want me to keep going?
Yeah, keep going.
Happy birthday
To
you. Cha.
Happy birthday to you. Happy birthday, dear Noami.
Cha.
Happy birthday to you. That went all over the place. Sorry, Karina, you got the song. Okay.
Keep going.
We were excited. No. All right. Let's come on back. Let's get out of this thing about. We'll say no, and then here we go. Kiddos, do you remember yesterday what we were working on?
Kind of.
Kind of, sort of, maybe?
Consistent and inconsistent. That was the last thing we did.
Weren't we doing row echelon and the stair step?
Yeah.
And then the three-dimensional planes?
Speaking of, when you do 7-3 homework, the stair step makes so much difference.
Yeah, right? That's what I
Oh my
thought.
gosh, she just showed you up. He's on slow. That's a really good question.
I don't even know I can.
Shenanigans happening. Okay, we're back. So number 32 is what we're trying to solve. And number 32 gives us the system of three equations, hence it's a three-dimensional system. 2x plus y plus 3z is equal to 1. 2x plus 6y plus 8z is equal to 3. And 6x plus 8y plus 18z is equal to 5. Get rid of this puppy even though we have the answer to make sure we're right. We gotta start doing it link by link, right?
Chair by chair.
Why am I putting a star next to him?
Because we want to change.
He's a keeper. He's a keeper, right?
He's a keeper.
Alright.
How cute.
So don't we go find our other two keepers?
Yeah, we do.
Alright, so the first thing we gotta do is make a link. First two. Alright, you guys, I'm gonna give you a 2-minute head start. Let's see how much of the math you can repeat. We're linking the first two, getting rid of the x terms. Linking the second two, getting rid of the x terms. Linking the remaining two that we just found and getting rid of the y terms. Then hopefully we have ourselves a stair step. Otherwise called row echelon form. Different ways of doing it. We might choose different ways, and so some of our work looks different. However, just try to stay somewhat in line with you guys. Did you make the top equation negative or the bottom equation negative? Okay, then I'll do the same. You guys get one more minute to try to get ahead of me. No pressure. No pressure. Just kidding. Wait, don't solve for y though.
Yeah, we gotta. Because we have to do the stair steps. We have to make it. And then the constant equation.
Yeah, we want to do z
You're getting
first.
rid of the x's and then just getting y by itself.
I got y by itself.
Don't solve for y by itself. Get y to have a 1 in front. So divide everybody by the number in front of y.
Yeah.
Then stop. Then stop. Get a 1 in front of y and then stop.
Anyone got c equals 0?
There's okay. jumped on. Ah, my turn.
Yeah, that's what we meant.
Oh, okay, okay.
Yeah, and then
Make sure you're. I'm coming. I made the bottom all negative, right? How's it looking?
good.
And what did I mean by get y with a coefficient of 1?
Put the z to the other side.
No. He's a keeper. Remember, we want a y and z for the second equation. We want a 1y for the second equation. Does that make sense? Now hold on, that was just the first link. What do we have to do now? Mhm. What do you guys do? Multiply the top one by -3? Checking it out. Looking good? Oh wait, except times -3, that's not -3. 2 times -3 is -2. I even tricked you guys. Tricked myself too. And once again, there are multiple ways of doing this, but we are learning the row echelon way, getting ready for matrices. So we are following a system. I'll talk more about that a little bit later today. The system would say, what do I do next? Can I, question. When I make a new link, do I have to keep that guy? I don't have to keep him. I already have a keeper for y, right? So now let's just link who I have, right?
With that, oh, okay.
Alright?
Okay.
Okay. I wanted to get y with the 1 in front just because he's gonna be my second stair step, right? So that's why I did that. But now we just need to go ahead and link the last two and just solve. So say, okay, here we go. Linking those two. Let's keep that -10 the way he is. I think he's fine, right? What am I gonna multiply the top one by to make him good?
Like 10.
So then 10 times 1 is 10y. 10 times z is 10z. 10 times 2 fifths is 4. We're using the last two links. Maybe they're a little bit too close. Let me kind of spread them apart. Does that help? And I multiply the top equation by a +10, so now it is ready to go, right?
Doesn't this other? Oh, you're adding them together.
Yeah, right?
Okay.
So now I have my 4z equals 0, and that's totally fine. Remember, we got to get a z with a coefficient of 1. So now let's divide both sides by 4, and I get z equals 0. And he is a keeper. So let's take our keepers. How many should we have?
3.
Hopefully 3. Let's take all our keepers and say, haha, we got ourselves a stair-step system.
And now we can solve.
Once again, there are different ways of doing this, but this is a system that will work every time. As long as there is a possible solution. Finitely many possible solutions. Those of you guys that worked on homework, maybe you didn't get all the way, but hopefully you got far enough to reinforce we love the stair step because
We can plug it back in.
we just go back.
And boom. Wait, then wouldn't y just be
Yeah, what would like be?
2, 5? How beautiful. This is gorgeous. Yeah.
Got 2. Now we go back again, right? Do you guys see me back substituting?
Yes.
So now I can plug in 2/5 plus 3 times 0 equals 1. We got this guy. That's just 0. 2x equals, isn't 1 5/5? 5/5, take away 2/5, and then divide by 2 or multiply by 1/2. Almost a 3-dimensional coordinate pair. Put the x and then the
Y.
and then the. Now we can say that's the one done.
Done. I love this chapter.
Does the system work?
Yeah, it does. I know.
Yeah, it does. Question: why is it good? Now hold on. This is a very kind of deep, very applicable to our day and age. Why is it good to have a systematic approach to solving a problem?
Well, let's see. Let me think about it for a second.
Improve our lives. Makes us stable.
Jesse just said you can use it for every problem of that type. Every problem? Every problem. A good system is a system that always works, right? Okay. What is something in this day and age that is booming that requires systematic thinking in order to solve problems? Huh? Computers.
Technology.
Technology, but why? Why does it require systematic thinking? Why, whenever, most people don't remember Mr. Muppet. You see him around campus every now and then. He's like the kind of shorter, white-haired dude that's hanging out with Mrs. Christensen that knows everything. Because he's amazing. He's like the technology advisor for New York Times. He was here for a long time teaching AP Comp Sci. He's probably like a millionaire. Anyway, he's basically a rock star. Why would he, when he was teaching here, come into my pre-calculus classes every year and say, you better take comp sci next year? What was he capitalizing on? Why was he telling them that they should be taking, out of everyone, they should be taking computer classes?
Use the application of
Systematic. What's systematic? Programming. Programming is systematic. Programming is to get from point A to point B. Can you follow a systematic approach to get there? And a systematic approach is one that will work every time for every problem of a certain type. Of a certain type. It requires systematic thinking. So, why am I showing you this system for solving the system of equations? Systematic thinking for systems. Anyway. Why am I showing you this approach? Because this is the approach that a programmer would want to think through. They would want to think through an approach that would work every single time. And why am I telling you this? What if we went back to, I think we had an example yesterday. Where is he? ¿Dónde está? Aquí. Right here. Could someone who's creative, could someone who's creative looking to solve this problem only this problem, not like future problems, just this problem. Couldn't they say, hey, why don't you guys maybe take this one, and why don't you cancel out the z's instead? Why would they see that and be like, oh, sweet, just cancel out the z's? Someone who's creative, just thinking about this problem, not about future problems, would say, whatever, cancel out the z's first. That's awesome in this problem. Any ideas? Maybe you guys don't think like this. Never mind. You like systems. What do you see right here? Just x's and y's. Why would they want to take these two and say, hey, let's get rid of those z's by multiplication?
So then you can
You have another equation with x's and y's, and then you can put those together and solve for x or y and have one answer you can plug in to solve for another answer to plug in both to solve for another answer. That actually probably in this problem would have been faster. So why did I not show you the fastest approach? Because that's only the fastest for
This.
this problem. If you go over to this problem and say, hey, let's get rid of the z's first. That's not.
Got it, Bob.
Right? So, it is a good skill to be able to look at a problem and find a faster way. However, it is also, and maybe even a more important skill, to find a system that you can follow for each. Does that kind of make sense? For a computer program has to be ready. Whatever you fill in for a certain option, it has to be ready to deal with that. And that's why making cards and thinking about artificial intelligence and all that stuff gets so hard. Because you have to think about, let's just say for a card game, you have to think about all the different possible options, all the different possible moves, all the different possible plays, and be ready for it. Which is cool. And it's a huge booming field, and there's a lot of money to be found in computer science these days. But it does require systematic thinking, which hopefully math is helping you develop. Anyway, all of that to say, 7-3A, dun 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 dun, 7-3B. That was fun. Oh wait, this is exactly the problem. I had it on a future page. We should sue. That's okay. It was my fault. Yes, you may. Ignore that page. I had it and didn't know it. Okay. Here we go. Let's keep going. Don't even worry about new section, new side. It's all 7-3, right? Let's just keep going. It's all 7-3. Let's just keep going. Because when you guys do your homework, just treat it like one homework, even though in past years I split it up. We made up time somewhere else. I think we took longer on 7-2 or something instead of taking longer on 7-3. Or like the chapel day fell differently this year or something. So we're good. What if there are not enough equations in the system? Wait, what? Not enough? They could give me not enough information? The shock, the horror. Heart of darkness. Is that a 12th grade book?
Yep, pretty bad.
Ooh, but there's so much meaning in it. You just have to figure it out.
It is. It is.
So many allusions to the depravity of man,
Mr. Payne?
the darkness of our own hearts, which lets God's grace
What
shine.
is the A really?
Which one are we going to talk about? Scarlet Letters?
Yeah.
Easy A? You guys just want it?
Yeah, okay. Sorry.
It wasn't a painting.
Olive?
That family dynamic.
This is still so passionate about these networks.
Is that the movie that has the whole, like, what you're adopting? Is that right?
Yeah, it is. It's with the. Yeah.
All of you guys read every single page of like that, right?
Really bad.
You did?
I'm not sure.
Should we pause for the confession going on right now? About how much you guys read or don't read?
I saw a commercial.
Multitask, keep it in your notes.
Yeah.
But Misty,
Are we ready?
this one only has two.
I know, what's wrong? Alright. We had fun with English, now we're back. Why did I bring up one of the most famous lines of 1994? Of the Heart of Darkness. The horror. Why? Look at this problem. Why did I bring up the horror?
Because it's spooky.
We're missing an entire
Remember the line when he's dying?
Good
The
one.
poor is he dies.
Shh. Missed the cut. He did. Anyway, so coming back. Question. Why don't we like two equations? Or what I would call as a non-square system. Wait, non-square. How many variables are we missing? 3. How many equations do we have?
2.
Ugh. 3 variables. We want how many equations?
3.
We want a 3 by 3 on the coefficient side. Wait, matrices, not yet. Next chapter. Anyway,
Oh.
hold on. Could your calculator solve one of these systems? No, it couldn't do anything. It would say error. It would say you put in the wrong number. Why? Because there are 2 instead of 3. But one. There will not be a unique solution. There will be an infinite solution, but look what we talked about this the other day. See if you remember it. There will be an infinite solution, but a restricted infinite solution.
So it's a line.
It's the one where
it's a line. It's not a plane. Okay.
It's not a plane, it's a line. This is a restricted infinite solution. Wait, what? There are infinitely many answers, and yet they are restricted. Well, how can we tell if they're restricted? Well, there must be some sort of formula, some sort of variable that can express the answers. And have infinitely many solutions, but in a restricted way. What do I mean? If we don't have 3, we, ready, make 3. But we can't set z equal to 1 number, because if they don't give me 3 equations, there must be infinitely many possibilities for z. Ooh. If they don't give us 3 equations, 3 variables, and they tell us to keep going, or to at least express the answers, then we say, fine, we need 3. So we'll say z is not a number, but a. And a represents all real numbers. Now hold on, if z equals a, what does y equal? Hold on. We don't know yet because we don't have a stair step yet. But do we have enough information to get a stair step?
Yes.
The answer is yes. So let's start following our system, which says to do what?
Pair up and
Right? Pair up and go. Are you guys going to multiply the top one by -2?
Yes.
Sweet, me too. Let's go. I'll give you guys 30 seconds. Just to let you have some fun and not just be copying down what I do. But multiply the top one by -2. Multiply the top one by -2. And let's eliminate. My turn in 3, 2, 1. You guys keep going, but I'm coming. Hopefully non-threatening way. Just in case some of you smarty pants are like, off my calculator, I'll cheat. Calculator can't even do this one. And number 2, who says you did a calculator?
Oh.
Ooh. Shots fired. Shots fired.
How are those shots? There's no threat. Just a challenge. Challenges aren't all bad. They make you stronger. When you face them the right way. What you guys got? 15 sixths? Hold on, double check my math. I can make mistakes too.
Wait.
I got 5.
It could be 5. Couldn't it be 5 over 2 because if you simplify it by 6?
Oh, I just didn't reduce all the way. Too much fun. There we go. 6 goes in. Follow the system. I guess we could. But since we're not a computer, do we really have to do the next link? No. Why not? Who's a keeper?
Because they're all. No.
He's a keeper. He's a keeper. And who did we make that can be a keeper right away? Oh, we already have our 3 keepers, right? All right. I'll allow you guys not to be computers right now. Let me go ahead and
Practice or right?
let's go.
Let me see.
Oh. Example number 2.
Wait, we gotta finish solving though, right? Get our stair step.
What's
Yeah.
What's the z equals a?
Remember, they didn't give us enough information to get a constant for z, which means z must be infinite.
Oh, okay.
So if z is infinite, then we just assign to him a variable. I'm going to always assign to him a. And then we're going to use him to to back substitute and find the restrictions on x and y. Okay, so I have my y equation, y plus 3/4 z equals 5/2, and then z equals a. Did we all get there? So we gotta go ahead and plug it in, but we already know z. He is a, and a means But if z is a, let's just make an example. If z is 1, we're gonna call it a, but let's just pretend. If z is 1, wouldn't there be a specific value that y would have to be?
Yeah.
Yeah, so let's go find it. Y plus 3/4. My example was 1, but let's go ahead and say, no, we'll keep the a in there, because we need to make formulas for these. Based on who z is, what would y need to become? Why am I going to multiply 5/2 by 2/2?
So then you can say 5 with 3/4.
Yeah, I wonder if that makes it any easier. So I would have 10/4 minus 3/4 a. Did I make that better, or would you guys rather have the separate fractions? Alright, let me go into it more clearly then. Let's just keep it. So we'll have 5/2. Then we're going to subtract the 3/4 a, right?
Mm-hmm.
Going to leave them like that? We can leave them like that. It's your choice.
Can we make it a 10/4 also, just so we have the same denominator?
Yeah, so you could. You could make it this
Gives you
one
that peace
equal
of
to y, or you could make it 10/4 minus 3/4, and the a would go with the 3. You could do either one, whichever one you like better is y. And I just leave it like that for right now because we still have to go back and plug it in some more. But either one is good. And we'll plug it in one more time. 2x plus 3 times. Which would you guys rather plug in? Second one or the third one? This one or this one?
Third?
Sorry, the top one or the bottom one? Let's do the bottom one. Bottom one? Alright, the bottom. So let me get rid of all this stuff then. And let's choose the other one instead. As you guys realize, either of them would have been okay, but since you guys like the looks of this one better, I don't mind. So we'll do 10 minus 3a all over 4 plus 3 times a equals 7. Now I know it's messy, but it's like algebra, kinda. Like we're plugging in and solving for. Except in this case, we're not solving for a, we're solving for x. He's the last guy we need. So what do you guys see?
Distribute the 3
Yeah, I can do that.
into the numerator.
So do 2x plus 30 minus, remember it's 3 over 1, so just distribute the 3 to the top. 30 minus 9a all over 4 plus 3a equals 7.
Can we put 3 in?
Yeah, do you want to get common denominator with 3a? Alright. So let's multiply 3a times 4 over 4. So we'd have 12a over 4 equals 7. Oh hey, can we bring this guy in? So 2x plus 30 minus 9a plus 12a, since they're all fourths, we can do that, right? Okay, cool. What's negative 9a plus 12a?
No, 3A.
Good, 3a. So I'm going to have 2x plus 30 minus 3a all
Plus
over 4.
Plus
Oh, nice, thanks. And now we can almost just solve, right? Move to the other side. 7 minus 30 plus 3a all over 4. Oh wait, can't we change 7 to fourths since we're doing the fourth thing anyway?
Hey.
Right. So that'd be 28 fourths. 2x equals, we can bring that 28 in. Yeah. Yeah, you seen it? So we get 2x equals negative 2 plus 3a all over 4. How do we get rid of the 2? Divide by 2 or multiply by 1/2. Do you guys see why I'm multiplying by 1/2? I have a fraction
It
here.
just makes it
Yeah.
visually.
Yeah, makes it better, easier, simpler. And we end up with negative 2 plus 3a all over 8. Woo! So we got it.
Right.
Now, how are these answers going to look funny? Put the 3 together. Negative 2 plus 3a all over 8. 10 minus 3a all over 4. And a. Meaning, even though z is infinite, who he is restricts who x and y can be. Does that make sense? So if z was 1, then we have to plug in 1 and get a y, we have to plug in 1 and get an x. It would be one specific point for 1. If z was 2, if z was 3, if z was 4, we'd have a specific x and y to go with. So it's not all numbers, who cares all numbers? It's like, well, z is all numbers and x and y are restricted. So that kind of makes sense, look good with the infinite but restricted.
Yeah.
What made this problem make us add in this whole z equals a thingamabobber? What was the characteristic?
Non-square.
It was non-square, aka we didn't have enough, so we said, fine, we'll make a third equation and make it infinite. Okay? Still possible, just a little bit crazy in your calculator. Yeah, it wouldn't be able to help you with that whatsoever. What about, what do we want to do? Let's do this guy. He's harder, and then we'll end on the easier one. An application. An application. While you guys do that, let me go see. I think I still have that file open. Let me go see if I can find the information, because I bet I wrote it down yesterday, and it will save us time. Okay, this is just an application of systems of equations. And systems of equations where you have 3 unknowns. And specifically, even though you guys don't see x and y and z, let me show you what your 3 unknowns are. A and B and S. Oops, is that frozen? Oops, let it go. Oh, not in the wrong one. Let's come back to this one. A and B and S. And if you're in physics, A should help you remember or think of acceleration. And if you're in physics, V would make you think of velocity. And if you're in physics, S might help you or make you think of position. So just real quick for you guys, because a lot of you aren't in physics, you can just put down to remind yourself really quickly. A is talking about acceleration. V, and technically V sub 0 is talking about like V of 0, when time is 0. It's talking about the initial velocity or the beginning velocity. And then S sub 0, which is the same thing as S of 0, means the same thing. Initial or beginning position. And just in case you don't take me for calculus, because we do some physics and calculus to help you for physics courses that might be coming, especially in college. These are types of problems they're getting used to or ready for, types of problems called free fall models, which could be something akin to, hey, there's this guy on top of a cliff, and you know what, he has a gun and he wants to shoot a bullet. Let's do it like a potato launcher, that's more fun. He has a potato launcher, and he wants to shoot the potato. And the potato, hopefully, as long as he's not in the moon, is going to go where? To the ground, and it's going to go kaboom. Okay, so, nice potato. We can find out all sorts of things, like how long will it take for the potato to be at the same height of the cliff? How long will it take for the potato to hit the ground? How long or how high will the potato go when shot at a certain angle, etc.? There's all sorts of math involved. And this is the equation that you would basically use. You would want to know how quickly the potato was shot off, that'd be the initial velocity, how high the cliff was it was shot off of, that'd be the initial position, and gravity, which would be acceleration. Oh, and gravity is probably mostly a constant. I say mostly for a very particular reason. Research it if you want to know why. Gravity is mostly constant. And so we memorize things like negative 32 feet per second squared and negative 9.8 meters per second squared. But anyway, long story short, that's not your guys' job right now. Your guys' job is to take given information, like someone is measuring what's going on. And after 1 second, they say the thingamabob, the potato, was at 132 feet. After 2 seconds, the potato was at 100 feet. And at 3 seconds, the potato was at 36 feet. So it hasn't hit the ground quite yet. Let's go ahead and take this information. I'm going to scroll up so I can see it with my notes. Let's see if you guys can figure out how to use systems to solve. Let me get the info down. So someone's measuring. This is like an out in the field example, or you're being given data information. After 1 second, position is 132 feet. After 2 seconds, the position is, and S stands for seconds on the left, sorry. S stands for position on the right. It's kind of confusing. 100 feet. And T equals after 3 seconds, the potato is at 36 feet. Now, our job is not to necessarily worry about all the crazy physics going on. Our job is just to say, hey, cool, they give me stuff, and they give me an equation. And we, as somewhat mathematicians, are going to say, hey, it's time to plug it in and plug it in. And you're going to plug in when S is, now I'm going to write it a little bit funny, when S is 132, I'm writing the S on the other side, so I'm switching the order. When S is 132, T would be 1. And if we plug in 1, 1 times 1 half A is 1 half A. Plus 1 times V sub naught, let's just call it V for sake of like making it simple, would be 1V. And then plugging in, there's nothing to plug in for S, so we say whatever, it's just S. The next one, we would plug in 100 for when T is 2. But T squared, 2 squared would be 4, and 4 over 2 would be 2, so we get 2A.
But they should have given you at least either the.
If it was
starting
physics,
speed.
Luca, I totally agree. This is kind of weird information. But since we're just looking at the math of it,
Okay.
it is acceptable. We'd have 9 halves A plus plugging in 3V plus S. They're asking us from these 3 data points to go ahead, and the bell's going to ring in to solve the system. We don't want to solve this system.
Yes, we do.
Well, we can. But some of you are like, there are fractions. Okay, fine. Wait. How do we get rid of fractions? Multiply by the denominator, and then follow the system to solve, right? Now, wait. You guys shouldn't get confused. This is all homework help. You shouldn't get confused on something like this, but you might. If they say solve with a system of equations, before I let you go, what on earth system of equations could you make?
X plus Z plus Y equals 180.
Because angles in a triangle add up to 180. How about angles that form a straight line? What do they
2x
make?
plus 7 plus Z equals 180.
Now you might have to be a little creative with this, but
2x minus 7 plus Y is 180.
shouldn't you be able to solve a system with 3 equations?
Yes, true.
That's what
Let's
we do.
go team. Bye guys. See you later.
Fine.
Just do it again tomorrow?
Yeah. 4-3 A and B. No, 7-3 A and B. Bye tomorrow.
Yeah.